Python comes with a number of useful libraries that we may want to import and use at some point. There are three ways to import a library. First, import library name, math in this example. Here, we import the header but not the content. So if you need an operation or a constant definition, you still need to use the library name as a prefix. So here, math.factorial or math.py. However, you cannot just write factorial or pi without the library name. The second syntax is used when you only need to use a specific operation or definition, such as the factorial function. In this case, you would write from library name import operation name. The third syntax is used when you need to use several operations. Then it makes more sense to load the whole library from library name import star, which means everything. Note in this syntax, you can't use the library name as a prefix. Here are some of the operations that you can find in the math library. In the following slides, we will go over defining functions in Python. Unlike Java or C, functions in Python don't have types when we define them. A function definition starts with the keyword def and ends with a colon. A function block is indented. And you may have input parameters, but function may not have these parameters. Finally, a function in Python may return more than one value. Function parameters in Python are passed using call by assignment, meaning it acts as call by reference for mutable data types such as lists, and like call by value for immutable data types such as strings. All assignments in Python use reference semantics. The code here shows a function that finds the product of two values passed as parameters. Then the value is returned. A function argument is the actual value of the function parameter when passed at runtime. A function argument can be anything with a value, such as direct values, expressions, variables, or even a function call. Default arguments are the values a function would take if the function call doesn't pass the arguments. But it's something that we have to set up earlier. Take a look at this multiply function. The parameters x and y are assigned two values, 10 and 20. Print multiply 10 and 50 is going to use the given arguments. But multiply 3 is going to use 3 for the x, and it will use 20 for y. Multiply without specifying any parameter is going to use the default parameters. The last statement shows that an assignment actually can be used when passing argument values, x5 and y equals to 3. All functions in Python have a return value, even when we don't explicitly write a return statement. Functions without a return value actually return none. None is a special constant in Python that is used like a null or void or nil in other languages. And as we have seen earlier, none is also logically equivalent to false. Python doesn't have a main function where the program execution would start. Instead, execution in Python starts at level 0 indentation. In this class, we will be creating our main function as needed. Here's an example. I have the factorial function written, and I created a main function, and I added the call to the main function at level 0 indentation. So when this program executes, it's going to the main, and the main is going to call the factorial. Next, we will talk about how to handle code that may produce an error that causes the program to terminate unexpectedly, such as runtime errors or just give an incorrect result. Examples of these errors are division by 0, opening a file that doesn't exist, trying to perform an operation that is not defined, such as an operation on numbers and strings, and so on. This code shows the syntax of exception handling. There is a try block where we add the code that may cause a runtime issue during execution. Then we should have at least one or maybe more except blocks. These except blocks treat one type of these errors. So if a division by 0 error happens, I want to do this action. If the error is type error, I'm going to do something else, and so on. So you can have multiple except blocks. But we don't know all type of errors. So to be on the safe side, we can have an except block without an error name, which means that if none of my except blocks cover the issue, so I want this except case to be executed. The else block is an optional block that gets executed when everything is okay with your code. None of these exceptions take place. And there's another optional block called finally. So in the finally, this is going to be executed always, and it's useful to do a cleanup code, closing files, and so on. Here's a simple illustration. So I wrote a program where I divide 1 by 0, which is going to cause 0 division error, and I wrote an exception case to handle it. Also, I added except, else, and finally cases. So when the program executes, this is going to cause a 0 division error, and this case is going to be executed, and I get 0 div. But this except case is not going to be executed because this error was handled by one of the exceptions. Also, the else is not going to be executed because I did have an exception in my program. So if I don't have an exception, then this is when the else gets executed. Finally, as we said, it's going to always be executed, so that's why I get finally printed. Finally, this is a more complex program for computing the quadratic formula, and many things can go wrong, like trying to find the square root of a negative number or divide by 0, maybe something else. So I encourage you to run this program and try to experiment with different inputs that may lead you to execute different cases. For example, you may try to input words like a string for the numeric and see if this case is covered and what you're going to get. So this is the end of this lecture. Thank you and good luck.